for number one of literal equations here, we are trying to solve for the x. So that means we're trying to get the x all by itself. Now we have to train our brains to say, well, if I'm getting the x by itself, I have to establish what I'm getting rid of first. And I see an a on the same side as the x, so I have to get rid of the a. I see a b on the same side as the x, so I have to get rid of the b. So now I've established I've got to get rid of the a, I've got to get rid of the b. But now the question becomes, which one do I have to get rid of first? So I look over here at my order of operations, and whenever we draw an upside down T, we do the reverse order of operations. So I'm looking down here at the adding and subtracting. I have to get rid of anything being added or subtracted to the x. So again, I have an a written right next to the x, which means multiplying, and a b, which is actually being added on to the x. So that tells me that I have to get rid of the b first. So to get rid of it, I'm going to draw an upside down T. The opposite of adding b would be subtracting b. So on the left hand side, I'm going to bring down my a times x, and on the right hand side, it says c minus b. Now, I can't combine them. They're not like terms. I can't put them together and say, oh, the answer is, and then make up a variable like d or f or g. I can't do that either. So I'm just going to bring it down and say c minus b. Now, my next step, again, is still to get the x by itself. The only thing that is still on the same side as the x is the a. And that a is multiplying the x. The opposite of multiplying by a is dividing both sides by a. So on the left-hand side, my a's cancel out. I bring down my x equals. And on the right-hand side, I get c minus b over a. And that's a fraction, and that fraction doesn't reduce. So I have my x by itself. So I am done with this problem. All right, with number two here. Again, we are trying to solve for the x. That's what it tells us at the top, solving for the x. Well, let's first establish what we have to get rid of. Well, if this is my variable, there's a 1/2 in front of my x, which means multiplying, and there's a y. So I have to get rid of the 1/2 and the y, and they're both being multiplied. Well, I like getting rid of the fractions first. So on this one, I'm going to get rid of multiplying by 1/2. And the opposite of multiplying by a fraction is not dividing. It is actually multiplying by its reciprocal. So again, the opposite of multiplying by a fraction is to multiply by its reciprocal. So on the left-hand side, I get x times y equals. On the right-hand side, I have 2 times z. So I'm going to write 2z. Please do not write that as z2. Okay? The coefficient goes in front. So 2 times z, not z times 2. All right, now from here, we are still trying to get the x all by itself. The only thing on the same side as the x is the y, and it's multiplying the x. So the opposite of multiplying by y is dividing by y. On the left-hand side, I get the x all by itself, and on the right-hand side, I get 2 times z being divided by y, and that fraction does not reduce, so I'm just going to leave it the way it is. So now my x is by itself, and we're finished. All right, for number 3, now we're solving for the b variable. So we have to first establish, well, what are we going to have to get rid of? There's an a and a c on the same side as the variable b. So we have to get rid of both the a and the c. Well, both the a and the c are multiplying the b. Now on this one, since they're both multiplying, I can get rid of them both. The opposite of multiplying by a and c is dividing by a and c. And again, I'm just going to get rid of those in the same step. So on the right-hand side, they both cancel out, and I get the variable b all by itself. And on the left-hand side, I get d divided by ac, and that's a fraction that doesn't reduce, so I'm done right here. All right, on number 5, we are trying to get the b by itself. So again, the first thing we always try to establish is what's on the same side as the b and a. So we need to get rid of the a. But here's the problem with that. If I was to say, what is the a doing? Like, is it adding to the b? Is it multiplying, dividing, subtracting? What is it doing? It's actually not doing anything. So the opposite of doing nothing, like, you can't do that. So if I can't get rid of the a the way it is, what I want to try to do is move the b to the other side. So the opposite of dividing by b would be to multiply by b. So I get the a all by itself equals, and c times b, You can write it as CB or BC. Doesn't matter which one. Most people put it in alphabetic order. I'm just going to write it like this. That way it's visually the same thing. You guys can see C times B. Now from here, I can get the B by itself. The opposite of multiplying by C would be dividing by C. So I get the B all by itself on the left-hand side, or the right-hand side, and on the left-hand side, I get A divided by C. All right, on number 8, we are trying to get the X by itself. So again, let's first establish, well, what are we trying to get rid of? I see a 1/2 on the same side as the X, an A on the same side as the X, and a B on the same side as the X. So now we need to figure out, well, which one do we get rid of first? Normally, the reverse order of operations say get rid of anything that's being added or subtracted first. So you would look at the B and say, well, let's get rid of it first. The problem with that is it's inside the parentheses. And the order of operations say do inside the parentheses first. But the reverse order, you don't do inside the parentheses first. You do the outside first. So on this problem, we actually have to pick between the 1/2 and the A. We got to get rid of these first. Now again, the 1/2 with fractions, I like getting rid of those first because it's kind of a special rule. So to get rid of multiplying by 1/2, I have to remember the opposite is not dividing. It's multiplying by the reciprocal. So I have 2 times C is 2C, and again, remember write that as 2C, not C2, equals A parentheses B plus X. Now again, we have to keep going. There's still an A on the same side as the X. There's still a B on the same side as the X. But again, normally we'd get rid of anything being added or subtracted. But this B is still inside the parentheses. And the reverse order says you have to do the outside first. So now I'm looking over here at the A. The A is multiplying. The opposite of multiplying by A is dividing by A. So now I have 2C being divided by A equals, and on the right-hand side, there's nothing outside the parentheses anymore, so I really don't need them. So therefore, I'm not going to write them. I'm just going to bring down my B plus X. Now my final step is to get the X by itself, and since there's a B being added over there, the opposite of adding B would be subtracting B. So on the right-hand side, I got the X all by itself. I brought down my equal sign. But on the left-hand side, I have a fraction 2C over A, and that is being subtracted by B. Those are not like terms, so I can't put them together. So I just brought it down and wrote it the way it is. 2C over A being subtracted by B. And now we're to standard form. The rules with standard form are, first, I always try to get everything in the exact order it's supposed to be in, and this is crucial. The number with the X has to be the very first thing you see. The number with the B has to be the second thing you see. The equal sign has to be the third, and the C, which stands for the constant or the number that's all by itself, has to be the very last thing. So again, if it's not in that order, that is our first job, is to put it in that order with upside down T's or just moving stuff around. So again, number with the X has to be first, number with the Y second, equal sign third, the constant or the number all by itself has to be last. So that's always our first goal. Now, once we get everything in the correct order, then we have to go and check these 3 rules. The A, or the number in front of the X, it can't be negative. If it is negative, we have to fix it, and I'll show you guys how to do that. The second rule, the A, the B, and the C, you can't have any fractions. So again, once it gets in the correct order, you got to look and say, well, I can't have any fractions. If it does, we have to fix it, and I'll show you how to do that here in a second. And then the last rule, the A, the B, or the C must be reduced. Okay? So if those numbers can be reduced, then you have to reduce them. So once you get them in the right order, always check these 3 rules. Okay? All right, let's look at number 1 over here. First off, the number with the X is the first thing we see. But is the number with the Y the second thing we see? No. So that's the first thing we need to fix. So I'm going to take that negative 3y and I'm going to move it to the other side. The opposite of negative 3y is adding 3y. So I'm going to bring down, and my 2x plus 3y are not like terms, so I can't combine them. But since the number with the x is the first thing I need to see, I'm going to put the number with the x first. And then the positive 3y. bring down my equal sign, and then bring down my positive 6. So again, let's check to make sure it's in the right order. The number with the x is the first thing I see. The number with the y is the second thing I see. The equal sign is the third, and the constant or the c value is over here all by itself last. So it's in the right order. So let's check our rules now. A can't be a negative. Well, my a value is the number 2. He's a positive 2, so we're good there. A, B, and C can't be fractions. Well, 2, 3, and 6 aren't fractions. Now the last one, it's a little bit more complicated without seeing an example of when to reduce it, but A, B, and C must be reduced. What I'm looking for is there a number out there other than 1 that I can take into 2, 3, and 6 and reduce them like I would reduce a fraction? And there isn't a number that goes into 2 and 3 and 6. There's no numbers that do that, so this is reduced. This is my answer right here. This is in standard form. Number 2, again, has to be in the correct order. So I look up here, is the number with the x the very first thing I see? And no, it isn't. So that's what I'm going to do first. I'm going to make sure the number with the x is the first thing I see. So I'm going to bring it over across the equal sign, and whenever you cross the equal sign, we use an upside down t. The opposite of negative 4x is adding 4x. Now, since the number with the x is the first thing I have to see, I'm going to write it first. So that positive 4x, I'm going to make sure that's the first thing I write down. Well, since the y and the number with the y has to be second, I'm going to put that positive y or plus y second. Then I bring down my equal sign, and then on the left-hand side, negative 6. Now, let's make sure everything's in the right order. The number with the x is first, the number with the y, and again, that's an invisible 1. Number with the y is second, the equal sign third, and the constant is over here all by himself. So let's make sure it passes our rules. Rule number 1, a can't be negative. Well, my a value, or the 4, is positive, so we're good there. Rule number 2, can't have any fractions. Well, I don't see any fractions anywhere. I have a 4, an invisible 1, and a negative 6. And the last thing is they have to be reduced. Well, 4, 1, and negative 6, there's no number other than 1 that'll go into those and reduce them, so this is reduced. This problem is written in standard form. All right, number 3. First off, let's make sure we get them in the correct order. The number with the x has to be first. Well, I have the number with the x. The number with the y has to be second. Well, that's right here. The equal sign has to be third. That's in the right order too. The constant, or the number all by itself, has to be last, and that's where it is. So this one is in the correct order. I don't have to do any upside down t's. But we got to make sure it passes all the rules. Rule number 1, the a value can't be negative. Well, this one is. So we need to fix that. In order to fix that, what we're technically doing is we're going to multiply everything in this by negative 1 so that they all flip their symbols. In reality, we're just flipping their symbols. But I wanted you guys to understand that technically we are multiplying everything by negative 1. So if I multiply by negative 1 or flip their symbols, this becomes positive 3x, because again, negative 3 times negative 1. This becomes negative 4y, because again, positive 4 times negative 1. And over here on the last part, negative 2 times negative 1, or just flip its symbol, becomes positive 2. So again, everything's in the right order, so let's double check our rules. Rule number 1, a can't be negative. Well, we fixed that. Rule number 2, can't have any fractions. I don't have any fractions. Rule number 3, has to be reduced. Well, 3, 4, and 2, there's no numbers that go into them that would reduce them, so this is considered standard form. Number 4, again, let's make sure everything's in the right order. The number with the x is first, the number with the y is second, the equal sign is third, and the constant is all by itself last. So everything's in the right order. Let's check the rules. Rule number 1, a can't be negative. We're good there. Rule number 2, can't have any fractions. Well, I have fractions right here. Okay, so we have to fix that. In order to fix it, we're going to do something called clearing the fractions. Clearing the fractions means you look at the denominators. Well, the denominator here is the number 2. The denominator here is the number 3. The denominator here is an invisible 1 on the bottom of that 4, because if I made that a fraction, it would be 4 over 1. So 2, 3, and invisible 1. I need the least common multiple of those 3 numbers. So I need a number that 2 will go into it, 3 will go into it, and 1 will go into it. For instance, 12. They'll both go into 12, right? But is 12 the least common multiple? No. There's actually a smaller number, 6. So the least common multiple is 6. Well, to clear the fractions, I'm going to multiply everything by the least common multiple. On the last problem, we multiplied everything by -1. On this problem, we multiply everything by the least common multiple of the denominators, which is 6. So 1/2 x times 6 is 3x. Plus 1/3 y times 6 is 2y. Equals 4 times 6, 24. So now again, everything's in the right order. It passed rule number 1. We've made it past rule number 2, no fractions. So let's check rule number 3. 3, 2, and 24. There's no number that goes into all three of them other than 1. So this is considered reduced and standard form. All right, number 5. It's in the right order. Number of the x, number of the y, equal sign, number by itself. So make sure all the rules. A can't be negative. We're good. Can't have any fractions. Well, I have a fraction right there. So again, I'm going to look at the common denominators. I have an invisible 1 here, a 3 here, and an invisible 1 over here. So I need a number that 1, 3, and 1 will go into, and the least common multiple is actually 3. So I'm going to multiply everything times the least common multiple, which is 3. So I get 9x plus 1y, or just y, equals -15. So again, it passed rule number 1. We've made it past rule number 2. And rule number 3, 9, 1, and -15. There is no number that goes into 9, 1, and -15 other than 1. So this is considered reduced. So this is standard form. Number 6. All right. The 10y is not supposed to be first. The 5x is supposed to be first. But do you guys see how they're both on the same side? I don't need an upside down t to move them around. They're already on the correct side. So instead, I'm just going to rewrite it, the positive 5x first, the positive 10y second. Now, let's make sure it meets all our rules once everything's in the right order. A can't be negative. We're good. That's a 5. Can't have any fractions. We're good there. But the third rule, it has to be reduced. Well, when I look at 5, 10, and 15, I know there's a number that goes into all three of them. That number is 5. Well, if I can divide all of them by 5, then I need to divide all of them by 5. So I get 1x, but I don't have to write the 1, plus 2y equals 3. Now everything's in the right order. This is standard form. With general form or slope-intercept form, and you'll see it called both things. I like calling it slope-intercept form, but Mathia, your book, test quiz, stuff like that, you might see general form. That just means get the y by itself. Okay, so this is just upside down t's to get the y by itself. So when I look over here, this is written in standard form, except it's not reduced. So I just need to get the y by itself. Well, the 2 is multiplying the y. The 6x is adding onto the y, and we have to get rid of anything being added or subtracted first. So I know I have to get rid of this 6x. So I'm going to do the opposite of positive 6x, which is -6x. I bring down my 2y equals. Now, up here in general form, it says the number with the x should go first, which is my slope, and then the y-intercept should go second over here. So when I rewrite it, it's not wrong if you put the 8 first, but I like to write the -6x first, the number of the x first, and then that positive 8 second. Okay? Then from here, again, we have to get the y by itself. The opposite of multiplying by 2 is dividing everything by 2. So I get the y all by itself. -6x over 2 will reduce to -3x. Positive 8 divided by 2 will reduce to positive 4. So this is general form or slope-intercept form. Number 2, again, we are trying to get the y by itself. Well, there's an 8 that is multiplying the y. There's a -4x that's actually subtracting because it's negative. So whenever we're trying to decide what to get rid of first, 8 is multiplying, and -4x or -4x is actually subtracting. And according to the reverse order of operations, we have to get rid of anything that's adding or subtracting first before the multiplying. So that's why I have to get rid of the -4x by adding 4x. So I bring down my 8y, bring down my equal sign. Now over here, 24 plus 4x, these are not like terms. I cannot put them together and say 28x. I cannot do that. But instead, I'm going to write the 4x first because up here in general form or slope-intercept form, the number with the x comes first. So I'm going to write that positive 4x first. Then I'm going to write that positive 24 second by writing plus 24. Now the last step to getting the y by itself is to get rid of that 8. The opposite of multiplying by 8 is dividing everything by 8. So I get y equals, now 4x over 8 reduces. 4 over 8 reduces to 1/2. So I have 1/2 x. Plus 3. All right, number 3. Again, we have to get the x by, or the y by itself. There's a 5x on the same side, but since that's positive 5x, it's actually adding 5x. Now, there's an invisible 1 right here between the negative sign and the y. So that's a negative 1 being multiplied to the y. Now, that's hard to see because that's an invisible 1. So that's a negative 1 times y. This 5x, because it's positive, is actually adding on. So to get the y by itself, I have to get rid of what's ever being added or subtracted, which is the positive 5x. So I'm going to subtract that 5x first. So I'm left with negative y on the left-hand side equals. Now again, I like putting the negative 5x first. And then that positive 3 would come second. Now from here, I am not finished because there's that invisible negative 1 right here in front that's multiplying the y. So I have to get rid of that invisible negative 1. Well, the negative's not really invisible. So the opposite of multiplying by that negative 1 would be dividing everything by that negative 1. So I get y equals positive 5x minus 3. And that is our slope-intercept form.